We will be talking about structures. Okay. So far we have seen arrays that hold only one data type, right? And we also saw primitive data types like integer, char, like that, float. But if you want to store all of them together, group them together in one variable, structures are very useful. For instance, you have a person variable to store, let's say, age as an integer, and let's say name as an array of strings or array of characters. So if you want to put, and maybe his height also, right? Height in float. So you have this kind of different kinds of data, and you want to store that in one variable. Structures are very useful, right? We will be talking about how to define a structure, how to declare a structure, how to assign two structures together. Can we compare two structures just like we did variables? Can we pass by value? So we'll be going over these concepts in this video. Okay, like we talked, structures provides us a, a, a variable to store all this information. In here, we define a simple structure, all right, with the two variables, x and y, and this is a tag name underscore point. For instance, I will erase that. The way you define is you use a keyword called struct, and we have a tag name. Tag names are always needed. It's better even though you don't need it, but we always use tag names. And we can say integer x, integer y. Semicolon is very important. So this is a simple definition. We are not allocating any memory with this definition, and it's a simple definition of a structure. So we can remove, we can place, for instance, where is the, remove the tag name and put a real name here, maybe a point. It's a tag name, right? So that's what we are defined, and by this we are not allocating any memory. Yeah, and in this case we are now, in addition to declaring a defining a structure, we are also defining a variable in the same declaration. Okay, we are doing two things together, defining it and declaring it. Okay, if you do point, now we are declaring two integers. One is x and one is y. We call the whole thing as point. And what kind of data type is this point? Is struct underscore point. The data type is struct underscore point is the data type, and we are allocating memory with two integers. This is a simple definition. And when you declare variables like that, how do you assign x and y values? Oh, if you want to assign some values to this, say 10 and 20, you simply say point x and point, just like you have done in Java class, right? Use equal to 10 equal to 20. So automatically we'll assign the 10 to the member variable x and 20 to the member variable y. All right? And printing is also same. And let's try to change our definition of another structure. Okay, in here we are now going to declare another structure. For instance, let's clear this up. Struct person, all right, character, name, say 32, integer, say age. Oh, this is not a character. Okay. Oops. Okay. And so this is again a simple definition with no memory allocated. Right? So we have defined 32 bytes for the name plus 4 bytes for the integer. So it equal to 36 bytes. But as we said, we are not allocating memory yet. If you want to allocate memory, you have to declare a variable, say person. Now, a person is a variable, a data structure with first 32 bytes occupies, let's say this is 32 bytes for the name and 4 bytes for the age. But care must be taken that it sometimes the optimization, because of optimization, the compilers will actually allocate more memory than what is required. In here, our memory requirement is 32 plus 4, which is 36 bytes. And sometimes it allocate more memory too. Try changing this, instead of 32, change it to 30. You know what I mean. If we change it to, now how much is that? It's 34, right? But in some compilers, you'll make it 36. Because they don't want to do 30 plus 4, which is not divisible by 4. 34 by 4 is not divisible. So they bump it up to 2 more bytes, which become 36 by 4, which is 9. So that's something you have to consider. All right. All right. So that is how you define a structure with a variable. And how do we copy a name in here? Now, how do I copy a name into this? Remember, this is char, right? Array of character. So we always use string copy, right? For the character. So that's what we are doing here. We are using string copy, profile name, user profile dot name, which is this, and we pass some name, some constant to the string copy to copy it. There's alternate way to declare variables using structures. Here we have not defined the variable along with the definition. We have separated those two things. We kept the definition separate and the declaration separate, right? So in this case, now how do we do that? How do we separate struct, right? Person, we say char, name, say 30, and integer, age. And when you put a semicolon here, we are only declaring a type. So in order to allocate memory, declare and allocate memory for a variable, we say struct in the main function or any function underscore person. You see why the tag name is important? And Sam or Dan. So we have two variables. One is Sam, second is Dan. Okay, of type this structure underscore person. And the minimum it will have 34 bytes, but it will have a little more than that. Okay, so this is one way of doing things. That is what this does. And here we have declared another variable, independent variable age. This variable and the variable inside the structure are totally different. They are different memories, and they do not belong to each other. For instance, I have declared another variable, integer. Outside the structure, I have age. Now this is a totally different memory. Okay, even though they share the same name, but this variable is different from the variable here. Okay, this variable, member variable age, belongs to this type, whereas this simple int age is a different variable. So we will stop at this. All right, the rest of stuff is very simple, but we'll go ahead and do some examples like we always do, right?